section, we're going to discuss operations and functions. In other words, what we have some given functions. From these given functions, we're going to create new functions. Sort of what we did on the previous section. We had a graph of the functions, and then by transformation or shifting upward or downward, or moving to the left or right, we created new functions. Now here we're going to start with more than one function. Like two functions f and g are given. So somehow we're going to use these two functions to create new functions using these two functions. Of course, these two functions both have their own domain. Like domain of f is t sub f, domain of g is t sub g. And we're going to learn what we mean by adding these two functions. When we add two functions, the result is a new function. So how do you define this new function, f plus g? Or if you subtract f minus g, what do you mean by this new function f minus g? Similarly, f times g and f divided by g. How do you define this? We basically define these pointwise. By pointwise means the following. The value of function f plus g at point x is obtained by finding the value of function f at x, value of function g at x, and then adding the both of them up. Okay? So we separately compute f of x and g of x, then we add up those two values, and the result is the value of function f plus g at x, because it's the name of a new function. Okay, and of course the domain of this new function is the intersection of the domain of the two functions. The domain, the part that belongs to both of them. So the same thing with difference between two functions. We subtract them pointwise, we multiply them pointwise or dividing pointwise, and then the domain, of course, of all of them would be the intersection of the domain of the participating functions, except that for the ratio division, we have to make sure that this denominator g is not 0 anymore. So the domain of the new function f divided by g is the intersection of the domain of the two given functions, except the values that makes the denominator 0. We have to remove those because we don't want to have the 0 in the denominator. Okay, so let's look at some examples here. Actually, if this is f of x, 3x plus 1, g of x is x squared minus 2x, and h of x is square root of x plus 1. How do you obtain f plus g at 4? Well, by definition, this is equal to f of 4 plus g of 4. Pointwise, we do f at 4 and g at 4, then add them up. F at 4, maybe I use bracket here. F at 4 would be 3 times 4 plus 1. You see, for f of 4, you replace this x by 4. And for g of 4, you replace these x's by 4. So it's going to be 4 squared minus 2 times 4. Actually, I should use parentheses around it. So 3 times 4 is 12 plus 1 is 13 plus 8, 16, 4 squared is 16 minus 8 is 8. So this is 21. G minus f at negative 3. By definition, this is equal to g of negative 3 minus f of negative 3 is equal to, let me change color here. F of negative 3. So g of negative 3 means replace this x in g by -3. Then minus f of -3 means replace this x by -3. So this is 3, -3 squared is 9 plus 6 minus -9 minus 1. So this is 15. This is -10 plus 10. So you get 25. H times G at 2. Well, by definition, you have to do it pointwise. So this is H of 2, we use bracket, times G of 2. H of 2, see, is the square root of 2 plus 1. G of 2 is 2 squared minus 2 times 2. So square root of 3, this is 4, minus 4 is 0, so you get 0 actually. F divided by H at 3. This is f of 3 divided by h of 3. F of 3 means in f replace x by 3, so you get 3 times 3 minus 1. H of 3 means here replace x by 3, so it's 3 plus 1. And this is 9 minus 1 is 8, square root of 4, 8 over 2, so the answer is 4. Again, we're gonna continue this type of exercise problems. Now we have 3 functions, a little bit different than the ones we had on the previous page. Now we're gonna find f plus g at x, general x, just not a number, any number x. Well, by definition, just like we had here, you just add the 2 functions, f of x plus g of x. Okay, so this is gonna be f of x plus g of x, this is equal to, let me change color a little bit. F of x is 8x plus 9, then plus g of x. G of x is x squared minus 2x. Now this is an intermediate algebra class, problem. Just remove the parentheses and add up the like terms and simplify. So 8x plus 9, because you have plus outside, you can remove the parentheses and leave everything the way they are. So plus x squared minus 2x equal. I start by simplifying, starting with x squared, and then 8x minus 2x gives you 6x, and then plus 9. Next one, f minus g at x. Similar situation, but minus in between. So I have f of x minus g of x. F of x is 8x plus 9 minus x squared minus 2x. Again, remove the parentheses, 8x plus 9, just leave it alone because you have plus outside, but here you have a negative outside of the bracket, parentheses. You can remove the parentheses but change the sign of everything that we have. So we get minus x squared plus 2x. Again, start with your x squared, then 8x and 2x, you get 10x plus 9. If, g divided by f at z, so this is g of z divided by f of z. What is g of z? G of z means replace this x by z, so you get z squared minus 2z. F of z means 8z minus 9. And basically done, but we have to see if we can simplify anything, but I don't see anything to be simplified, so that's the end of it actually. F times g at x, so it's f of x times g of x. We multiply the functions. See, one more time to show you this. See, pointwise. F plus g at x is f of x plus g of x. F minus g is f of x minus g. F times g, f of x times g of x, and so forth. Okay, so I'm just using formula. F of x is 8x plus 9 times x squared plus 2x. But this is nothing but an intermediate algebra question. Just FOIL it. X times x squared, you get 8x cubed, 16 x squared plus 9 x squared, and 18 x. So 8x cubed, 16x squared, 9 more x squared, I get 25 x squared plus 18x, and that's the end of this one. One more. This is not written nicely, but this is actually equal to h of z divided by f of z minus 3. H of z is square root of, you see, this is z right here. H of z means replace this x by z, so you get 2z minus 1. Square root of 2z minus 1, and f of z, this is f of z is 8x minus 3, then I just add 3 to it, so it's 8x minus 9 minus 3. This is f of z. See, f of x is 8x minus 9, so f of z becomes, so let me rewrite the denominator. F of z is 8z minus 9 minus 3. That's the denominator. So square root of 2z minus 1. And then if you simplify the denominator, you get 8z minus 12. And that's the end of it actually. You cannot simplify this any further. more examples. Okay, more examples. In the previous examples, we actually had the formulas for f and g, and we did f plus g, f minus g, and so forth. Here, you don't have the formula for f and g, but what we have are the graphs of f and g, and we're going to compute f plus g at 4, f minus g minus f at -2, f times g at 1, and f over g at 0. How would I do that? Well, we continue by writing what this means. This means f of 4 plus g of 4. So I have to find f of 4 and g of 4 from the graph. So what I would do, I go to the graph here, f of 4. For f of 4, this is function f. I start at 4 and go all the way up to get to the function f, and then I go horizontally, then I get to this number. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So f of 4 is 9 plus. Then g of 4. G of 4, again I start at 4 and I go all the way up to get to function g. This is function g right here. Get to this point and then I go horizontal. I got to 2, so plus 2. So the answer is 11. G minus f at -2. Here's a -2. So I rewrite it. This is g of -2 minus f of -2. And this is equal to g of -2. This is -2. See, g there is not defined here. You see, there is no g. G only goes for values from 0 to infinity. So g of 2 not defined. Because this part is not defined, it doesn't matter what this one is, the whole thing is not defined. Okay. F times g at 1. Now you do at 1, here's 1 right here. So this is f of 1 times g of 1. F of 1 means that you start at 1 and you go all the way up to get to g, to f, and from f you go horizontal to get to y-axis, and this is 1, 2, 3. So this is actually 3 times g of 1. G of 1, you see, you get to g, and from g you get here, you get 1. So this is 1. So you get 3. F over g at 0. This is f of 0 divided by g of 0. F of 0, you see, f of 0, and from 0 you get to g, you get 1. G of 0 is 0. So this is undefined. Sometimes we have values in the table, and then similar questions are asked. Like we have this table given to us, and first row gives the values of function f of x for various values of x. Second row gives you the value of function g at similar values of x. Then we want to compute these values here. F plus g at 4, which is by definition f of 4 plus g of 4. This is equal to f of 4. You see, this is f. If I go to 4, I get 9. g of 4. G of 4, if I go to 4 for x, you get 5. So I get 14. F minus g at 4 is f of 4 minus g of 4. Of course, again, I have the same number. 9 minus 5, you get 4. Maybe I should have used, actually, well, doesn't matter. F times g at 1 is f of 1 times g of 1. F of 1, f of 1, see, f1 is 3, g of 1, g of 1 is 1. So we get 3. F times g, so f of 0 divided by g of 0. F at 0 is 1, g at 0 is 0, this is undefined. Let me add one extra here, let me do an E. It's say f plus g at negative 2. This is f of negative 2 plus g of negative 2. F of negative 2 is negative 3 plus g of negative 2 is undefined. So the whole thing is undefined. So we did review this quickly before we continue the next concept. So we had these 4 operations here. I mean, familiar operation like addition, subtraction, multiplication, and division. And notice that for multiplication I use a dot. So every time you see a dot or nothing between the functions, it is multiplication. Something like if I have f dot g or fg. These both means that you are multiplying the functions, okay? But if I put another symbol in between, f circle g, that we're going to study now, that would mean something different. So don't think that the circle means multiplication. No, the circle means something else. We call it composition, and that's what we are about to study. Okay. Okay, more examples. The previous examples, we actually had the formulas for f and g, and we did f plus g, f minus g, and so forth. Here, you don't have the formula for f and g, but what we have are the graphs of f and g, and we're going to compute f plus g at 4, f minus g minus f at negative 2, f times g at 1, and f over g at 0. How would I do that? Well, we continue by writing what this means. This means f of 4 plus g of 4. So I have to find f of 4 and g of 4 from the graph. So what I would do, I go to the graph here, f of 4. For f of 4, this is function f. I start at 4 and go all the way up. So we get to the function f, and then I go horizontally. Then I get to this number. What is that? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So f of 4 is 9 plus. Then g of 4. G of 4, again I start 4 and I go all the way up to get to function g. This is function g right here. Get to this point and then I go horizontal. I got to 2, so plus 2. So the answer is 11. G minus f at negative 2 is negative 2. So I rewrite it. This is g of negative 2 minus f of negative 2. And this is equal to g of negative 2. This is negative 2. See, g there is not defined here. You see, there is no g. G only goes for values from 0 to infinity. So g of 2 not defined. Because this part is not defined, it doesn't matter what this one is, the whole thing is not defined. F times g at 1. Now you do at 1. Here's 1 right here. So this is f of 1 times g of 1. F of 1 means that you start at 1 and you go all the way up to get to g to f, and from f you go horizontal to get to y-axis, and this is 1, 2, 3. So this is actually 3 times g of 1. G of 1, you see, you get to g, and from g you get here, you get 1. So this is 1. So you get 3. F over g at 0. This is f of 0 divided by g of 0. F of 0, you see, f of 0, and from 0 you get to g, you get 1. G of 0 is 0. So this is undefined. Sometimes we have values in the table and then similar questions are asked. Like we have this table given to us, and first row gives the values of function f of x for various values of x. Second row gives you the value of function g at similar values of x. Then we want to compute these values here. F plus g at 4, which is by definition f of 4 plus g of 4. Is equal to f of 4. You see, this is f. If I go to 4, I get 9 plus g of 4. G of 4, if I go to 4 for x, you get 5. So I get 14. F minus g at 4 is f of 4 minus g of 4. Of course, again, I have the same number. 9 minus 5, you get 4. Maybe I should have used, actually, well, doesn't matter. F times g at 1 is f of 1 times g of 1. F of 1, f of 1, f1 is 3, g of 1, g of 1 is 1. So you get 3. F times g, so f of 0 divided by g of 0. F at 0 is 1, G at 0 is 0, this is undefined. Let me add one extra here, let me do E. It's say F plus G at -2. This is F of -2 plus G of -2. F of -2 is -3 plus G of -2 is undefined. So the whole thing is undefined. So we did review this quickly before we continue to the next concept. So we had these 4 operations here. I mean, familiar operation like addition, subtraction, multiplication, and division. And notice that for multiplication I use a dot. So every time you see a dot or nothing between the functions, it is multiplication. Something like if I have f dot g or fg, these both means that you are multiplying the functions. Okay. But if I put another symbol in between, f circle g, that we're going to study now, that would mean something different. So don't think that the circle means multiplication. No, the circle means something else. We call it composition, and that's what we are about to study. Okay. Okay. All right. Now, but we're gonna do another operation on functions. This is called composition. Had addition, subtraction, multiplication, and division. Now we're gonna have composition. Okay, composition is like you just explain this in a silly way. Actually, let's say you want to go from a city A. Let's say from Little Rock. Actually, why not? From Little Rock, you want to go to Los Angeles, LA. Okay. And those of you who have taken this trip before know that there is no direct flight from Little Rock to LA. Most of the time, you have to go to Dallas, and then from Dallas go to Los Angeles. So what happens? From Dallas, so let's say this is X is U, okay? So from Dallas, you take, from Little Rock, you take one airline, let's say you take airline G. You take airline G, fly from Little Rock to Dallas. So when you get to Dallas, you are G of X, okay? So this is U, now you became G of X, means you are in Dallas. Then from Dallas, you take another flight, let's say flight F, to get to Los Angeles, but this is U, G of X is U. So when you get to Los Angeles, you're gonna be F of G of X, see? But not G of X is U, it's the whole thing. So F of whole thing, okay? Then, this is kind of silly that we have to do 2 flights. So somebody says, I think there is a new airline that goes directly from Little Rock to Los Angeles. Like, that would be nice. And then you say, what is the name of that? You say the name of that is F circle G. That's the name of this new airline. Therefore, if this is UX in Little Rock and you take this flight, this company F circle G, then you will be in Los Angeles, so you would be F circle G and X. But because this is, after all, this is you in Los Angeles either way, so these two must be equal. So F circle G at X is the same thing as F of G of X. Okay. F of G of X means in F, replace all the X's by G of X. So this is how you define composition of a function. You see, you have one function. You see, this is the set X. You are X here by function G. This function G, take X, make it to become G of X. And then G of X now by function F becomes F of G of X. But if you go directly from X from the beginning to the end and bypass this one in the middle, then is actually F circle G. I call it F circle G. So this point is the same thing in either way. So F circle G at X is exactly equal to F of G of X. So another way to do this is like, you know, there is a function, this is this box. Okay, there's this box here, and then this is function G. You put X in it, then G of X comes out. Then there's another machine here. You put G of X in there, the name of this machine is F. Then when you put G of X in there, then what goes out? F of G of X. Now we can combine these two machines and make one single machine. Call it F circle G. Then you put X in there, then F circle G and X comes out. So these two must be equal. See? So basically that's what we have. I don't worry about the domain of it. Circle G. So let's just not worry about the domain actually. So what we have, this example, are two functions, F and G, and we want to compute F circle G at 2, G circle F at -3. Remember, these are not multiplication, these are composition. For F circle F at 4, and then the next page we have a couple more examples on the next two pages. Okay, so what is F circle G at 2 means? Means F of G of 2. Okay, so I need G of 2. You see, you need G of 2. So here on the margin, what you do, you go to the margin right here on another scratch paper, compute G of 2. That's what you need. You need G of 2. G of 2 is 2 squared minus 5. You see, this is x squared minus 5 for G of X, so G of 2 becomes 2 squared minus 5. So it's 4 minus 5 is minus 1. So G of 2 is minus 1, therefore this is nothing but F of minus 1. That's what G of 2 is. G of 2 is minus 1. Then F of minus 1, you replace X by minus 1 is your F, so this is -3 times minus 1 plus 2. This is plus 3, 2, you get 5. G circle F at 3. By definition, this is G of F of -3. So you need F of -3. Again, I go to the margin and compute F of -3. F of -3 here, you see, is -3 times -3 plus 2. You get 9 plus 2 is 11. So f of negative 3 is 11, so this is actually g of 11. Now what is g of 11? G of 11 means replace x by 11 in g, and this is your g right there, x squared minus 5, so you get 11 squared minus 5, so it's 121 minus 5, 160. F of 4, you see, you use the same function twice, composition of a function by itself. So this is actually by definition is f of 4. So I need f of 4. So if I go to the margin, so let me separate this margin here. I need f of 4, you see. So f of 4 is equal to, this is f of x, the negative 3 times 4 plus 2 is negative 12 plus 2 is negative 10. So f of 4 is negative 10, so this is f of negative 10. And f of negative 10 means your f replace x by negative 10, so minus 3 times minus 10 plus 2, this is 32. Another example. Same idea. Now here you're gonna do it for general x, like this is your f of x and this is your g of x. You wanna do f circle g at x. So this is by definition f of g of x. But g of x is square root of 2x plus 1, so this is f of square root of 2x plus 1. So f of this whole thing means in your f replace x by all of that, so negative 3 times square root of 2x plus 1, okay, then plus 2, and that's about all you can do. There is, can't simplify this any further. G circle f at t. So this is g of f of t. But f of t from f of x is obtained, it becomes g of f of t is negative 3t plus 2. So in g I replace this x by 3t plus 2. So square root of 2 times negative 3t plus 2 plus 1. And you can simplify a little bit, not much. So if you multiply, you get negative 6t plus 4 plus 1. So finally it's negative 6t plus 5. Again, similar question but different functions. Actually, I don't want to find the domain. It becomes a little bit, complicated, so I'm not gonna open a can of worms, in other words, and make it a little bit simpler for you guys as well. So this is by definition f of g of x. So a g of x is this guy square root of x plus 1, so is f of square root of x plus 1. So that means in your f, oh sorry, I didn't do it right, it's equal to f of g of x. G of x is 4x plus 2. So that means in your f, replace this x by 4x plus 2. 4x plus 2 for x, then plus 1. And then if you do one more simplification, you get 4x, 4 times 2 is 8, and 1, 9. Circle f at t, so this is by definition g of f of t, but f of t would be square root of t plus 1. That's what f of t is, you see. F of t is the square root of t plus 1, and this is equal, now in g replace this x by square root of t plus 1, so it would be 4 times square root of t plus 1 plus 2. Last example of this section actually is an example in which we're trying to recapture the functions that we have composite. In other words, if circle G is this function, we want to know what your f is and what your G is, so that when you write f circle G, you get that back. So in a sense, basically we look for those functions f and g among those parent functions in section 3. Those simple functions, standard, we call them parent function. We can use those functions to construct new functions. So a little bit of thinking. Well, of course, f circle G at x is the same thing as f of g of x. That means that there is a g of x that has been replaced for all the x's in f. So if you have an f and you have replaced all the x's by g of x, this is what you get. So what do you think that g of x is that you have replaced all the x's by? So I put g of x to be, you see, x squared minus 5, x squared minus 5. So I call this one x squared minus 5. So seems like x squared minus 5 have replaced whatever that you had here for f, which is x. So f of x therefore is, this whole thing is squared. We call it x squared because x has been replaced by that. So if I remove that, I have to replace it by x, you see. And if I remove this, I replace it by x. So I get x squared minus 4x minus 3. You see, these are the f and g I'm looking for, because if I do f circle g, I get the same thing back. You see, f circle g x is f of g of x. That means in f, which is this guy here, this is f of g. G is x squared minus 5, you see. So that means in your f, which is this function here, all the x's have to be replaced by x squared minus 5. We get x squared minus 5 squared minus 4 times x squared minus 5 minus 3. So I check, you see. So it worked. Now look at this next example. Sometimes there is more than one answer. Okay, like this example down here is one of those type of examples that you get more than one possibilities. So what do you think? So this is gonna be g of f of x. So I'm looking for a function f that has replaced all the x's in g. So by a little bit of looking around, this is actually a matter of experience. The more of these problems you do, the better you get at it. Okay, the reason I can do it quickly because I've done it so many times. So it's not really difficult to figure out what your g of x, f of x gonna be. F of x is the inside function, so I call f of x to be 2x minus 5, or square root of 2x minus 5. And then I put g of x to be 4 over x. Now if you look at g circle f at x, which is g of f of x, that means in g you have to replace all these x's. So this is g of f square root of 2x minus 5. This is check, I should say. And g of square root of 2x minus 5 means replace this x by all of that. So it's going to be 4 over square root of 2x minus 5. And this concludes this section. Now you can watch this video over and over. If you have any difficulty, you can watch it more than one time. And please watch the other videos related to this section. So